Namaste, welcome to my channel Qubit Educational Services. I am Pranesh. I am the founder of Qubit Educational Services and an IISc Bangalore alumnus. In this video, we are going to solve the mathematics questions from the IISER Aptitude test 2022. Previously, I had already uploaded a video on IISER Aptitude test 2022 mathematics questions, but those questions were from a different set. And in this video we are going to solve the questions from that paper which you can find on the IISER Aptitude tests official website. So we will start our solutions with the first question from probability. A randomly chosen card from a deck of 52 cards is given to be a black card, that is spade or a club. What is the probability that it is either a face card or a spade? And we have four options: 8 by 13, 9 by 13, 19 by 26 and 7 by 13. The solution is extremely simple. The sample space here consists of 52 cards. Okay, the sample space consists of 52 cards, but our modified sample space will only consist of 26 cards because it is given that the card is black. Okay, so let me call that as our event B. So the number of elements in that set will be 26. Okay, 13 spade cards and 13 club cards. We need to find the probability that it is either a face card or a spade. Now note that out of those 26 cards, 13 will be spade, right? And the remaining 13 will be club cards. Now they are asking us the probability that it is either a face card or a spade card. So in our required event, these 13 spade cards are already there, right? Because we want the card to be either a spade or a face card. Now how many face cards are there corresponding to each deck? There are 3 of them, right? So a king, a queen and a jack of a spade card, a club card, a heart card and a diamond card. Correct? And in sets, when we take union, we do not count the recurring or repeating elements twice, which means the face cards of spades will already be counted in those 13 cards. And what is left now is the 3 cards, the 3 face cards of club. Correct? So the event A, if we call our event as event A, then how many elements are going to be there in it? There will be 13 spade cards and then there will be 3 face cards of club, right? So there will be 16 elements in A. So what is the conditional probability? Okay, so what is the probability of A given B? The probability is very simple to find now. It will be 16 number of elements in A upon number of elements in B. Number of elements in A is 16, number of elements in B is 26. 16 by 26 is 8 upon 13, and that is option A. Correct? So question 1, option A. Very simple question. You can also solve this question by using the formula for conditional probability, but the sample space being only of 52 elements, we just modified it and got the answer. Let's now go to question 2 on complex numbers. Let omega be a complex root of the quadratic polynomial x squared plus x plus 1. The value of omega plus 1 upon omega into omega squared plus 1 upon omega squared, so on till omega raised to 100 plus 1 upon omega raised to 100 is, and we have got 4 options A, B, C, D. If you observe closely, the quadratic polynomial that is given to us, x squared plus x plus 1 equal to 0, we have seen this polynomial earlier, or we have seen this quadratic equation earlier. This quadratic equation or polynomial arises when we are finding the complex cube roots of 1. Correct? When we are finding complex cube roots of 1. Because essentially when we are finding complex cube roots of 1, we are solving the equation x cube minus 1 equal to 0. And if we apply the formula a cube minus b cubed, which is a minus b into a squared plus ab plus b squared, Okay, if you equate it to 0, this part gives us x equal to 1, and the remaining part, x squared plus x plus 1, that is the given polynomial, quadratic polynomial. This is going to give us two roots. If we call one of them as omega, the other one will automatically become omega squared. You know, all of you know this theory part, right? So we will now write down the equation 1 plus omega squared equal to 0. That is the main equation which we will make use of in solving this particular problem. Additionally, I will be writing omega plus omega squared as negative 1. I'll tell you why once we see the solution, once we begin the solution. And of course, omega cubed will be equal to 1. That's by definition. Now, these things here which I have written in the red box, this is what we will need to solve the problem. Observe that this whole set of 100 terms, there are 100 terms which are being multiplied. Omega plus 1 upon omega is the first, and omega raised to 100 plus 1 upon omega raised to 100 will be the last. Now let us consider the first three terms in the product. First three terms in the product. The first term is omega plus 1 upon omega. Can we now not write this as 1 plus omega cubed by omega, because 1 is omega cubed, that's what we have written here. And this will allow us to write omega cubed upon omega as omega squared, and again returning back to the red box, omega plus omega squared is negative 1, so this is negative 1. Okay, now go to next, omega squared plus 1 upon omega squared. Keep omega squared as it is, again write 1 as omega cubed. Omega cubed upon omega squared will again be equal to omega. Again go back to the blue part, omega plus omega squared is negative 1, so that's negative. And finally go to omega cubed plus 1 upon omega cubed. Omega cubed is by definition 1, 1 plus 1 is 2. Okay, so first three terms in the product, what is their value? Negative 1 into negative 1 into 2. So negative 1 squared into 2, or just 2. Now that's important, because now if we take, suppose, the next three terms, what will they be? Next three terms. Now you begin to realize that when I write omega raised to 4 plus 1 upon omega raised to 4, I know that omega cubed is 1. So this is as good as omega plus 1 over omega, correct? When I write omega raised to 5 plus 1 upon omega raised to 5, because I know that omega cubed is 1, omega raised to 5 will be omega squared itself, and this will be again omega squared plus 1 upon omega squared. And no matter, no question about omega raised to 6 plus 1 upon omega raised to 6, that is going to be 1 plus 1, that's 2. So the thing is, each terms, okay, rather if we group all these terms into a group of 3 each, then we have 33 such triplets, starting from omega plus 1 upon omega till omega raised to 99 plus 1 upon omega raised to 99. Okay, if you group them in 3 each, then there will be 33 terms. Why 33 terms? Because 33 into 3 is 99. So we are grouping them into, well, a group of 3. So there will be 33 such things. Now, what is individual product being, well, rather, what is the value of the individual product? It's 2. So every 3 terms, if you take, the product will give us 2, correct? Therefore, value of the product will be equal to 2 raised to 33 into the last term, that is omega raised to 100 plus 1 upon omega raised to 100. We all know that this is nothing but omega plus 1 upon omega, and its value is ready. Omega plus 1 upon omega is negative 1. Look here, omega plus 1 upon omega is negative, and just put it here. So that will be negative 1 into 2 to the power 33. Negative 1 into 2 to the power 33, that is again option A. Okay, so question 2, option A. Question number 3. Let f of x be a n x to the power n plus a n minus 1 x to the power n minus 1 so until a1x plus a0 be a polynomial. Suppose that f of 0 is 0, df by dx at x equal to 0 is 1, d2f by dx squared at x equal to 0 is 4, and d3f by dx cube is equal to d5f upon dx raised to 5. Now it's a polynomial, and well, it's fine that we are given f of 0 equal to 0, df by dx at x equal to 0 is 1, and d2f by dx squared at x equal to 0 is 4. But what's more important is the last equation that's given to us, this one. Why? The reason is we currently do not know the value of n, that is the degree of the polynomial. Okay, the degree of the polynomial is equal to n, and it is not known to us right now. But if you go back and take a look at this blue boxed equation, you'll immediately realize that the degree must be equal to 2. The degree of the polynomial must be equal to 2. Why is that? Because they're saying third derivative is always equal to the fifth derivative. Okay, third derivative of a function, of a polynomial function, for all values of x is equal to the fifth derivative of the function. Now, no polynomial can exist except for a polynomial whose third derivative is equal to 0. And because its third derivative is 0, all consecutive derivatives will automatically become 0, and that is the only way we can realize the situation third derivative is equal to fifth derivative. So if you now understand that the degree is 2, let's bring back our quadratic thing, ax squared plus bx plus c. Right now we can make use of all the three equations to determine the values of c, b and d. F of 0 is 0. This clearly means that c is 0. So f of x is ax squared plus bx. Now what will f dash of x and f double dash of x be equal to? Okay, f dash of x will be 2ax plus b and f double dash of x will be 2a. Now they are saying first derivative's value at x equal to 0 is 1. Okay, so they are saying f dash of 0, which is b, it's 1. Okay, so b's value is ready, b is 1, and they're also saying that second derivative's value at 0 is 4. F double dash of 0 is 4, but f double dash of x is a constant, it's 2a, so a's value must be equal to 4. A's value must be equal to 2 because 2a is equal to 4, so a must be equal to 2. So now we have all three coefficients, right? A is 2, so 2x squared, b is 1, so x, and c is anyway 0, so no need to write it. And finally we need to find its value at 5, therefore f of 5 is equal to 2 into 5 squared 25 plus 5 55. That is option A. So first three questions so far, 1, 2 and 3, all of them are option A. Okay. Question 4. Let S be the set of all unit vectors in the xy plane. Then the set S has infinitely many elements, 2 elements, 4 elements and 8 elements. Now the question is very simple. We know that in xy plane any vector of the form cos theta I cap plus sin theta j cap is a unit vector. Let's call it u cap of theta because it is now a function of theta. Okay, and if you find the magnitude of all these vectors irrespective of the value of theta, the magnitude is 1. Correct? So this answers actually the question, because they want us to determine how large the set S is. It clearly will have infinitely many elements, so correct option is A. Now you might think that how can they ask such an easy question? Well, it's their choice, but I'd like to add one point here. In your later courses on linear algebra, that is the extension of determinants and matrices, you'll study things called vector spaces or something like that, and there we are actually required to use an idea which we call linear dependence or linear independence. I'm sure you must have studied all these things in vectors as well, correct? And now we also know that in 2 dimensions, if you take any vector, okay, if you take any vector, then you can always express it as a linear combination of 2 linearly independent vectors. Okay, 2 linearly independent vectors. Okay, so if you take any 2 linearly independent vectors in the xy plane, okay, that is called as the basis of that vector space. Okay, and the number of elements in the basis is called the dimension. Okay, the number of elements is called as dimension of that particular space. Now if you want to determine the dimension here, then that dimension will be 2, because if you, let's say, take the vector I cap along x direction, let me call it b1 cap, and if you take b2 cap as the unit vector along j cap, any other unit vector, well, not only unit vector but in general any vector can be expressed as a linear combination of these two, I cap and j cap, but they themselves are linearly independent of each other, because you can't have j cap as a multiple of I cap, and you also cannot have I cap as a scalar multiple of j cap. So if they had asked us how many maximum, well, let me put it in this way: how many vectors can you have from the set which are linearly independent, the maximum number, and that is 2. That is 2, but that is not the answer to the question 4. 2 elements is the answer to how many linearly independent elements or unit vectors can we have in the xy plane, and the answer is 2 to that. Options C and D are, well, I don't think they make any sense at all. So question 4, option A. Question 5. A lab reports that global average temperature in the year 2020 was 14.9 degrees Celsius and predicts that the global average temperature will increase at the rate of 1% per year. What will be the global average temperature in the year 2035? And we have got 4 options. This is a simple problem, and the principle on which it is based is the same using which we calculate the compound interest. Okay, because it is increasing at the rate of 1% per year, so this 1% will be the increase will be of the previous year's temperature. Okay, which basically means that the temperature in the year 2035 will be given by the temperature in the year 2020 into, now every time it is increasing at the rate of 1% per year. Now 1% increase is actually equivalent to the temperature of 1 plus 0.01. So this will be the temperature in the year 2021. In the next year it will be the square in the year 2022. In the year 2023 it will be the cube of this. So in the year 2035, which will be the 15th year, if you count it, it will be 1 plus 0.01 raised to 15. Now here is something which I'd like to emphasize. If you have the on-screen calculator, which I'm sure you will have, then if you calculate the value of this t2020 into 1 plus 0.01 raised to 15, then it gives us the precise value. I will calculate it now, that's one thing. Okay, I'll tell you the next part later. So let's first calculate it. T2020 is 14.9 into 1.01 raised to 1.01 raised to 50. That is 17.298. Now observe carefully. 17.298 is there in option A. So being the most accurate among the four, we must select option A. Now some of you might think 0.01 is an extremely small number. It is 100 times smaller than 1, and we have got a large enough power here. Why not we use linearization, which is an approximation to the binomial expansion of 1 plus x raised to n, which is 1 plus nx. We often use this approximation in physics. Many times we have used it, especially in that electric dipole expression, which I can recall, in that derivation where we use the cosine rule to find potential at a point. We actually use that linearization. We don't consider the higher terms there. Okay. But now if you approximate it, here the point is, if you approximate it, it's 14.9 into, so this is now 1 plus 15 times 0.01. Now this approximate answer is also there in the options. If you see, 14.9 is there, and now instead of raising 1 plus 0.01 to 15th power, I'll just be multiplying 14.9 by 1 plus 15 into 0.01. Okay, I will be multiplying 14.9 by 1 plus 15 into 0.01, and that is 17.135. that is option C. Okay, that is option C. So which of the two options are you going to select? My recommendation would be, if on-screen calculator is available, it means you have to use it. So option A. If on-screen calculator is not there, which doesn't mean you couldn't find it. If it is there, then you have to mark option A. If it is not there, it will not be accessible to anybody who is writing the exam. In that case, the linearization will be the preferred choice. In that case, we'll mark option C. Otherwise, you will mark option A. Question 6. Let X be the set of all 2 by 2 matrices with real entries, and let R, a subset of the Cartesian product X cross X, be the relation R equal to the set of all ordered pairs A comma B such that AB is equal to BA. Which of the following statements is true? R is reflexive and symmetric but not transitive. R is reflexive and transitive but not symmetric. R is symmetric and transitive but not reflexive. R is an equivalence relation. Now we know that the general property of matrix multiplication is that it is not commutative. So in general, it's not commutative. Okay, in general, AB is not equal to B. Now here they are saying that if we have two such matrices which commute each other, okay, so we can call them commuting matrices. So when AB and BA are equal, we call A and B as commuting matrices. Okay, we call them commuting matrices. So when such a pair of matrices exists, we will immediately include it in our relation R, and we have to decide whether our relation is reflexive, symmetric, transitive, or all three, which is equivalence. Okay. Now proving the reflexivity is not difficult, so let's start with reflexivity. Okay, now in reflexivity we want the elements of the ordered pair to be identical. Okay, so A into A is A squared, so it doesn't really matter which A you write first. Okay, so this is true for all A, isn't it, in X, so it is reflexive. Now is it symmetric? Of course it is symmetric. Okay, so given AB equal to BA, it will also mean that BA equals AB, isn't it? Which means, or this implies, if A comma B, the ordered pair of matrices A comma B, belongs to R, then automatically B comma A also belongs to R, because if AB belongs to R, AB equals BA. But that also means BA equal to AB, equaling AB, which means B comma A also belongs to R, and therefore it is symmetric. and therefore it is simple. Okay, now is it transitive? It's not transitive. Okay, I'll prove that to you now. Now here's the thing, if you want to prove something, you have to consider the general case. But if you want to disprove something, then even one counter example is enough, and that is what we are going to do to solve or to show that it is not transitive. Correct? So I'm going to say let I be the identity matrix of order 2, 1 0 0. Now we know that for all A in the set X, AI is equal to IA equal to A. We all know this, that identity matrix commutes with any matrix of the appropriate size. Correct? Now we are going to consider two matrices. Let's call them P and Q. So let's say P is 1 2 3 4, and let us consider Q as 5 6 7 8, some random matrices. Now observe that P comma I belongs to R, right? Because Pi is equal to IP. And also observe that I comma Q also belongs to R, because I into Q is Q into I, and that is equal to Q. Now for transitivity, we would like to see that when P comma I and I comma Q belong to R, does P comma Q belong to R? That is the question that we need to answer. Okay, so let us just determine the first element in the product PQ. Okay, to get this element, we need to consider the first row of P and first column of Q, right? So that will be 1 into 5, 5 plus 2 into 7, that's 14. So here if we do it, you will get 5 plus 14, so that's 19, right? So PQ11 is 19. Now what about QP? For QP, what we need to do is, we need to consider first row of Q but first column of P. And how much is that? That will be 5 into 1 5 plus 3 into 6, that's 18, right? 5 into 1 plus 6 into 3, so that's 5 plus 18, and how much is that? That's 23. Now because the very first element itself in both these matrices is different, they're not same, PQ cannot be equal to QP, which means P comma Q, the ordered pair, does not belong to R. This is enough. One counter example is enough to disprove any result. So therefore not transitive. Okay, therefore not transitive. And so it is reflexive and symmetric but not transitive. Option A. Okay, reflexive and symmetric but not transitive. Option A. Question number 7. For a natural number n, let Cn be the curve in the xy plane given by y equal to x raised to n, where 0 is less than or equal to x and x is less than or equal to y. Let An denote the area of the region bounded between Cn and Cn plus 1. Then the largest value of An is 1 upon 6, 1 upon 2, 1 upon 3 and 1 upon 12. Now what we will first do is, we will first try to find the function An in terms of n, correct? And then we can very easily check for its maximum or its minimum value. Okay, so we have y equal to x raised to n, and x lies between 0 and 1, right? So this is in general the equation for the curve Cn. Now we can very easily point this out, but you should be well aware of how the graphs of y equal to x, y equal to x squared and y equal to x cubed, and in general y equal to x raised to n behave in the patch 0 to 1. Okay, if you believe that y equal to x squared lies above y equal to x in that range 0 to 1, then you are wrong. Okay, so here is what you will find if you go to any plotting software and plot the graphs of y equal to x. So red is y equal to x, blue is y equal to x squared. So if you take any number, let's say half, okay, which is in between 0 and 1, and if you square it, you'll get a number smaller than that. So half squared is 1 upon 4, half cubed is 1 upon 8. So every time when you square that number, it is going to decrease. That means in between origin and the point 1 comma 1, as you increase the power, what is going to happen to the value? It is going to decrease. Correct? So y equal to x squared is going to be below y equal to x, and now if you go to y equal to x cubed, it will be further below y equal to x squared. Okay, so if we now wish to develop the expression for an, what should it be? It will be 0 to 1 x raised to n minus x raised to n plus 1 dx. Right, that's pretty straightforward because all our graphs are above x-axis, passing through origin and passing through the point 1 comma 1, and they share no other point of intersection except for 0 and, well, except for origin and 1 comma 1. The expression for an is right. That is the area bounded between the two curves. Okay, it's not very difficult to see that the integral of this, which will be x raised to n plus 1 upon n plus 1 minus x raised to n plus 2 upon n plus 2, when substituted with limits 0 and 1, is going to end up with 1 upon n plus 1 minus 1 upon n plus 2. Okay, now what do they want us to determine? They want us to determine the largest value. Okay, now this largest value is when the denominators are the least, and you can also see that from the graph. Between n equal to 1 and n equal to 2, if you see, the graph has the larger area than between n equal to 2 and n equal to 3. So an max will be 1 upon 2 minus 1 upon 3. So that will be 1 upon 6. That is option A. Okay, well, now if you don't find this explanation convincing, then we can go for 1 upon 3 minus 1 upon 4. So that will be 1 upon 12, right? And if we now go to the next one, that's 1 upon 4 minus 1 upon 5, then it is going to be 1 upon 20. Okay, so basically you are going to get a sequence which will be decreasing. Okay, well, could have simplified this further as well. We could have simplified this, and it is n plus 2 minus n plus 1, n plus 2 minus n plus 1, that is essentially 1 upon n plus 1 into n plus 2. Now when can this be maximum? It will be maximum when the denominator is minimum, that is when the value of n is the smallest. N smallest is n equal to 1, being a natural number, that's n. So our answer is right, because this largest is when n is least, and that is largest when n is equal to 1. So n is equal to 1 will give us 2, n equal to 2, well, n equal to 1 again will give us n plus 2 as 3. So that's 1 upon 6 square units, and hence the correct option is A. Question 8. Let f be a continuous function on the closed interval 0 to 1, and let f be its antiderivative. If capital F of 0 is 1 and integral of small f of x from 0 to 1 is 1, then capital F at 1 is 2, 0, 1 and half. They have given us that capital F is the antiderivative of the given f. Antiderivative means integral. So we can now say that integral of f with respect to x is f of x plus c. That's what this is telling us, right? F is its antiderivative, and we can have infinitely many antiderivatives due to the fact that derivative of a constant is 0. Now, to get the value of the constant of integration for this particular function f, we need to go to the next. Okay, they're saying f of 0 is 1. Now how are we going to incorporate this particular piece of information in our equation? That is where the fundamental theorem of integral calculus comes into play. We are going to say integral from 0 to x f of t dt. Now by definition, what will this be? This will be f of x minus f of 0. Like that's what we do when we wish to evaluate any definite integral, isn't it? Now have they given us f of 0? Yes, they have. That is 1. Therefore, this is equal to capital F of x minus 1. That's given. Now they want us to determine f of 1. So x's value is still 1. Therefore, integral 0 to 1, that's x, f of t dt is equal to f of 1, again f of 1 minus 1. But what is this integral here? What's this integral? They've given us the variable in the definite integral being a dummy variable. This value will be matching with this value. Okay, so clearly f of 1 will be equal to 1, that is the value of the definite integral of the function, minus 1. It goes to this side, it becomes plus 1, so that would be 2. So f of 1 is 2, option A. Question number 9. Let a be a non-zero real number and f be a function from R to R, and let it be a continuous function such that f dash of x is positive for all x in the set of real numbers. Consider the function g of x given by f of 2a squared x minus ax squared. Then g has local maxima at a if a is positive, local maxima at a if a is negative, local minima at at a if a is positive, and d a point of inflection at x equal to a. Now to begin with, what we need to look for is, we need to look for the derivative of the function. Now this being a composite function, we will first be differentiating the outer part. That's f prime of 2a squared x minus ax squared. This must be multiplied with what? The derivative of the inner function with respect to x. So that will be 2a squared minus 2ax. Now when g dash of x is equated to 0, what are we going to get? If g dash of x is equated to 0, well, now observe that, okay, so observe that this part f dash of anything is always going to be positive. No matter what value you plug in, it is always going to be positive. So the only possibility that g dash of x equal to 0 is left with 2a squared minus 2ax equal to 0. 2a squared minus 2ax is equal to 0. But now again they are saying let a be a non-zero real number. Now if a is non-zero, we can cancel a now. In fact, we can take 2a common and a minus x equal to 0, which gives x equal to a. So that's the only I would say real value. That's the only value where g dash of x is equal to 0. Okay, that's the only value where g dash of x is going to be equal to 0. Okay, now let's take second derivative of g with respect to x. Second derivative of g with respect to x. Second derivative. Okay, now we are required to differentiate g dash of x with respect to x. So we will now be applying the product rule of differentiation. Derivative of the first function, so that is f double prime 2a squared x minus ax squared into derivative of the inner function will be 2a squared minus 2ax. So effectively it is going to be 2a squared minus 2ax the whole squared, because well, the one of these two terms is from the already existing second function and the other one is from the derivative of the inner function of f prime. Okay, plus first function as it is, f dash or f prime 2a squared x minus ax squared into derivative of the second function. 2a squared is derivative 0 being a constant, so what will there be? There will be negative 2a. Okay, now observe that if we substitute x as a, then due to 2a squared minus 2ax, this expression will always be equal to 0, no matter what f double prime 2a squared x minus ax squared is. Okay, plus well, now what will this be? F prime 2a squared x minus ax squared, again for the very reason that f dash of x is positive, this will also be positive, isn't it? This will also be positive. Okay, so let's call it a positive number. Let's call it a positive number into negative 2. Okay, now according to the second derivative test, by second derivative test, okay, according by second derivative test, we now need to ensure that the sign of g double dash a, okay, by second derivative test, a function has a local maximum when the second derivative is negative. Okay, so say g has a local maximum, when g double dash at that particular point is negative. Now what does this mean? This means if x is if a is positive, g double dash of a will be negative because it is a positive number, some positive number, into negative 2 into a. But if a is positive, negative 2 into a will be negative. Negative, that number into positive number will again be negative. So local maximum. Correct? Okay, so is do we have this option by the way? Local maximum when a is positive. Local maximum when a is positive. Okay, so option A is tentatively correct. But we now need to see if at x equal to a we have something which we call an inflection point. Okay, we have an inflection point. Now, where do we have an inflection point? If we take an example of function like y equal to x cube, where do we have, or what condition is there when we have y equal to x cube as an inflection point? Look here. This is where the function has an inflection point at x equal to 0. Now here, first derivative is 0, but the second derivative is also equal to 0, isn't it? If you differentiate, y prime will be 3x squared. When you equate it to 0, you'll get x equal to 0. But what about the second derivative? Second derivative is also 0. But in our case, second derivative is not 0. It is negative. Well, of course, if a is positive. Right? So I hope you understood that inflection point possibility is to be ruled out, because for the inflection point, the second derivative should also be equal to 0. Okay, and then we have to analyze it further. So correct option to question 9 is A. That is now confirmed. Local maxima at x equal to a if a is positive. Question 10. Let A be the matrix cos theta 0 negative sin theta 1 1 1 sin theta 0 cos theta. For any natural number k, the determinant of a to the power k is 1, negative 1 raised to k and 0. To solve this problem, we are going to make use of the fact that the determinant's value is independent of theta. Correct? And because it is independent of theta as indicated by the options, we can choose any value of theta as per our convenience to decide the determinant of a raised to k, and the obvious choice will be theta equal to 0. So let's see what happens if we substitute theta equal to 0. So what will a be? Cos theta 1 sin theta 0 1 1 1 0 0 and 1. Now if k is 1, suppose if k is equal to 1, then what will be the value of the determinant of a raised to k? It is essentially determinant of a itself, right? So what is determinant of a now? It's 1. 1 into 1 minus 0, so that's 1, and the other two elements are 0. So when k is 1, it's 1. So definitely D is not right. Negative 1 raised to 1 is negative 1, C is not right. Negative, okay, so this is 1, so negative 1 is clearly not there, so option A is the right option. Okay, option A is the that option. So this is the shortcut way to solve the problem. If you want to solve this problem by the, I would say, standard method, then how would you go about doing it? We will be making use of the property of the determinant, that determinant of product of two square matrices of the same size is actually equal to determinant of A into determinant of B, which means the determinant of A raised to K is actually determinant of A raised to K, right? So what we basically now require is the value of the determinant of the matrix A itself. Okay, so let's now find it. Let's now find the determinant of this particular matrix. Okay, so let me chop this. Okay, so that's the determinant of A. How much is that? Cos theta into, okay, cos theta into cos theta, so that's cos squared theta. Okay, perfect. Cos squared theta 0, so no need to write it, minus sin theta into 0 minus sin theta, so that's again plus sin squared theta. So the determinant is forever 1. No surprise that at theta equal to 0 we got the determinant to be 1, right? Well, because it is independent of theta, we were expecting that the same thing. So even if we had not evaluated it the other way, it would have still given us the same answer logically. But anyways, question 10 is option A. It is independent of, okay, so the determinant of A raised to K is independent of theta and K, all of them, no matter what the value they take, the determinant's value will always be 1. Question 11. Consider the vectors A bar equal to I cap plus xj cap plus 2k cap, B bar equal to I cap plus 2j cap plus xk cap, C bar equal to 2I cap plus j cap plus 3k cap. The values of x for which there is at least one non-zero vector perpendicular to the vectors A bar, B bar and C bar are 0, 2, negative 2, 2, 7 by 2, 0, 4, negative 2. Now this problem is based on the fact that if we want a vector, a non-zero vector perpendicular to 3 of them, then we must have the condition that A bar, B bar and C bar are coplanar. Only then you can draw a vector which will be mutually perpendicular to all 3 of them. So when A bar, B bar and C bar are coplanar, it means their scalar triple product A bar dot B bar cross C bar is equal to 0. Now when it is equal to 0, it means the determinant 1x2, 12x, 213 is equal to 0. Now what we need to do now is we need to expand the determinant, get the equation, I guess it's quadratic because of the two values of x, and then we have to solve that equation to get the answer. Okay, so 1 into 6 minus x into 3 minus 2x plus 2 into 1 minus 4, so that's negative 3. So 6 minus x minus 3x plus 2x squared minus 6 equal to 0. 6 goes, or rather 6 and negative 6 go. So this will be 2x squared minus 4x equal to 0. Take 2x common. X minus 2 equal to 0. So either x is 0 or x is 2. X is 0 or x is 2. That is option A. It's a fairly simple problem. But you have to first realize what exactly the problem is telling you, and what is the conclusion that the problem that you can draw from the problem based on the information that you already know about coplanar vectors or vectors in general. That's question 11. Question 12. Consider the tangent lines to the circle x squared plus r squared equal to 1 at points p equal to 1, 0 and q equal to 1 by root 2, 1 by root 2. If r is the point of intersection of these two tangent lines, then angle PRQ is 3 pi by 4, pi by 4, 5 pi by 6, pi by 6. Okay. Now we all know that if our circle is has its center at the origin, then the equation of the tangent is x1 plus y1 equal to a squared, where a is the radius of the circle and x1 and y1 are the coordinates of the point where the tangent is being drawn. Correct? So the tangent at P, which lies on the x-axis, well, we know already that it is now going to be a line x equal to 1, right? But we can still look at it by using the formula x into x coordinate plus y into y coordinate equal to square of the radius. So x equal to 1, so this is our y-axis. Well, sorry, a line parallel to y-axis to 1, 0. At Q, 1 by root 2, 1 by root 2. What's the tangent at this point? Well, it's actually x1, so x into 1 by root 2 plus y into 1 by root 2 equal to 1. In other words, the line is x plus y equal to root 2. Okay, now we need to determine the point of intersection of these two tangent lines, that's R, and we have to also find angle PRQ. Okay, let's try to see if we can solve this problem graphically. Okay, so suppose this is our, okay, let me draw it here. Suppose this is our circle. These are our axes, x and y. Okay, now clearly the point 1 by root 2, 1 by root 2, it is going to lie on y equal to x, correct? So if we now draw it here, the line, okay, that's 45. So here is going to be our point P. Okay, so we need to now draw a line tangent to this. What angle should it be making? Negative 40. Yes, that's right. So this is the tangent at Q. Let me draw it in red color. Okay, this is the tangent at Q. So this is Q. Okay, and the equation is x plus y equal to root 2. Now what about point P? Let me use blue color for that. At point P 1, 0. So this is our point P. So this is going to be our tangent at P. Okay, this is going to be a tangent and this point is P. Okay, now what is the point of intersection of the tangents? R. R is the point of intersection of the tangent, so this is R. Okay, this is R. Now what next? Angle PRQ is what they are asking us to determine. Angle PRQ, that means they want us to determine this angle. Now there is no hesitation or whatsoever now, because this angle has to be 135 degrees, isn't it? The red tangent being x plus y equal to root 2, its slope is going to be -1, so this angle has to be 135 degrees. Okay, this angle has to be 135 degrees, so this will be 45, this will be 45, so this will also be 45. Okay, that means that the acute angle between the two tangents is going to be 45 degrees, but we want the obtuse angle, not the acute angle, PRQ. That angle will be 135 degrees or 3 pi by 4 radians, option A. Correct? 12th option A. Question 13. The function given by f of x equal to 2x cube minus 15x squared plus 36x minus 5 is increasing on the interval 0 to 2, decreasing on the interval -3 to 0, increasing on the interval 2 to 3, and decreasing on the interval 3 to infinity. I think this is a fairly straightforward problem. We have to first find the derivative of the function f. So that will be 6x squared minus 30x plus 36. We may take 6 common, so it will be x squared minus 5x plus 6, right? Now see, if we want the function to increase, we would like to find the sign of the derivative of the function. It's not difficult to factorize it. X minus 3 into x minus 2, those will be the factors. Now let's consider a number, or let's consider a value of x which is greater than 3. This is where f dash of x is positive, because everything is positive. And if we consider a number which is less than 2, even then x minus 2 will be negative, x minus 3 will be negative, so again the function will be increasing. and when x lies between 2 and 3, the function will be decreasing, because when x minus 3 will be negative, x minus 2 will be positive in that range. You have to pick the option correctly. Increasing on the interval 0 to 2. Well, that's right, because when x is less than 2, f dash of x is positive, and x is less than 2 means from negative to negative infinity to 2, and our interval 0 to 2, that actually belongs to this, right? The interval 0 to 2 actually belongs under a subset of negative infinity to 2, so that's the right option. Is it decreasing on the interval negative 3 to 0? No, it's actually increasing, because negative 3 comma 0 also belongs to negative infinity comma 2. Oh, sorry, okay, wait. It's decreasing on the interval negative 3 to 0. Yeah, okay, yeah, that's right, sorry. Negative 3 to 0 belongs to negative infinity 2, so that's right. Okay, it's not decreasing, it's actually increasing. Increasing on the interval 2 to 3, that's not right, it's negative, so decreasing. Decreasing on the interval 3 to infinity, again not right, because it is increasing. Okay, so that is option A for question 13. Question number 14. The value of the integral 1 to 100 box x upon x with respect to x, where box x is the greatest integer function, or like greatest integer less than or equal to x for any real number x's. Now we can actually split our integral into simpler sub-integrals where the box x's definition will be different. Okay, so we will start doing that. Integral 1 to 100 box x by x dx is equal to. Now observe that when our x is in between 1 and 2, 1 included, 2 excluded, but that hardly matters in the definite integral. It will be 1 upon x, because the value of the greatest integer function in between 1 and 2 is always 1, plus when you go from 2 to 3, the box x's values will become 2, so it's 2 by x dx, right? So in between 3 and 4 it is 3, in between 4 and 5 it is 4, and what will we have at the end? At the end we will have 99 to 100, 99 by x dx. Okay, let's use the summation notation now to get this. Summation as r goes from 1 to 99, integral of, okay, now we can say r to r plus 1, r to r plus 1, r by x dx. Let's check it again. When r is 1, it is 1 to 2, 1 upon x. When r is 2, it is 2 to 3, 2 by x. When r is 3, it is 3 to 4, 3 by x. And when r is 99, the last one, it is 99 to 100, 99 by x dx. Okay, can we integrate this? Yes, of course we can. So as summation, r goes from 1 to 99. Okay, so let's take r here. Integral of 1 upon x is log x, so it will be ln r plus 1 minus ln r. Now here is the main step. Usually what we will prefer is, we will prefer combining ln r plus 1 and ln r and write it as ln r plus 1 upon r. But that's not what we want to do here. That's because of the options. So we are not doing this. We are not doing this. It's right, but we don't want it as of now, because our options contain factorials and powers. Okay, so we can now write this as summation as r goes from 1 to 99, r ln r plus 1 minus summation as r goes from 1 to 99, r ln r. Okay, so let us first write down first few terms of the first series to get an idea of what our pattern is going to be. R is 1, so it will be ln 2, r2, 2 ln 3, r3, 3 ln 4, r4, 4 ln 5, so on till So suppose our R is 98. So it will be 98 ln 99 and the last value 99 ln 100. Okay. Now suppose we write R as 1. So 1 ln 1, that is 0. So we will not write it. Let's go to 2 ln 2. So that's 2 ln 2. And everything will now have a negative sign. So negative 2 ln 2 minus, or let's put just minus outside. Okay. Now R is 2. So 2 ln 2, that's done. R is 3 now. So it will be 3 ln 3. Then 4. So 4 ln 4. Then 5. So 5 ln 5. So until now, when R is 98, it will be 98 ln 98. So let me not write it. When R is 99, it will be 99 ln 99. That's it. You don't have 100 here, let me tell you that, because that's R ln R and R ends at 99. Okay. Now if you observe, we have negative ln 2, negative ln 3, negative ln 4, negative ln 5, all up to negative ln 99. So it will be negative of ln 2 into 3 into 4 up to 99. Let me explain it one more time. The coefficients of ln 3, they differ by 1, rather negative one, right? Because 3 ln 3 has a negative sign. Same thing applies to a coefficient of ln 4, coefficients of ln 5, coefficients of ln 98 not shown, coefficients of ln coefficients of ln 99. So 98 ln 99, and here it is 99 ln 90. So all of them will basically get clubbed together plus 99 ln 100. Now I'm writing it as ln 100 raised to 99 only because of the options we just saw there, right? It was some power of 100. So let's use the property of logarithms to make 99 as power of 100. Okay. Now what is this? This is ln 100 to the power 99 minus ln 99 factorial, like 2 into 3 into 4 up to 99, as well as 1 into 2 into 3 into 4 into that. Okay, so that's ln 100 raised to 99 upon 99 factorial, and that is option A. Okay, 14th is done. Now let us go to the last question from the website paper of IISER Aptitude Test 2022 Mathematics. Question 15. For arbitrary constants alpha beta, the differential equation representing the family of curves y equal to alpha x plus beta into e raised to xs, and we have got 4 options. Now I'll tell you a shortcut to solve this problem. Okay, I'll tell you a shortcut to solve this problem, and this shortcut works only for the differential equations which satisfy some criteria. Okay, in particular we call those differential equations as linear, homogeneous differential equations, okay, or ordinary differential equations. Well, in your higher classes you will also learn partial differential equations, but as of now let me just say linear homogeneous differential equations. Okay. Now you have already studied homogeneous differential equation as a type in your current differential equation course, or in your calculus course I would say, but as you go higher and higher, the term homogeneous differential equation is defined rigorously as follows. A differential equation having at least one term in dependent variable or its derivatives, or the unknown function y and its derivatives in each term. Like say for example, take a look at all these differential equations. In each term we either have y or its derivatives, or we can even combine them together. Okay, but here we also want them to be linear, so each term can have only one y or one derivative of y. Okay, all of them have right hand side 0, so there isn't any term left in all these options which doesn't contain y or its derivatives. When that is the case, we call them homogeneous differential equations. Okay, anyways, so this works in general for any nth order, but let me specifically mention it for second order. Okay, So the second order differential equation is what we now have, because our general solution has two arbitrary constants. Okay. So here is the trick, the shortcut. The shortcut says replace y double prime by m squared, replace y prime by m, and replace y by 1. So you will basically get a quadratic equation, right? You'll basically get a quadratic equation which could be of the form am squared plus bm plus c equal to 0. Okay, we preferably make it m squared. So, well, obviously we know that a is not equal to 0, otherwise it will not be a second order differential equation, right? So form it as m squared plus b by a into m plus c by a equal to 0, and we have to solve this equation. Okay, now we know that a, b, c are real numbers, so we now consider three possibilities. First possibility is that the roots m1 and m2 are real and distinct. When this is the case, then the general solution is y equal to c1 e to the power m1x plus c2 e to the power m2x. That's case 1. If m1 and m2 are real and equal, then the general solution is y equal to c1x plus c2 e to the power m1x, and if m1 and m2 are complex conjugates, they have to be, because the quadratic equation has real coefficients. When they are complex conjugates of each other, let us say m1 and m2 are alpha plus or minus I beta, then y is given by e to the power alpha x c1 cos beta x plus c2 sin beta x. Okay, you remember this trick. You'll study this in your next ordinary differential equations or calculus course. Okay, now which one of the solutions matches with the given differential equation or given solution? Alpha x plus beta into e to the power x, that is basically referring to this, right? Alpha x plus beta e to the power x, which means we need to now pick a differential equation whose equation of this kind, we call it an auxiliary equation. We call it an auxiliary equation is 1. So it has both repeated roots, and therefore that equation becomes m minus 1 the bracket squared equal to 0, or m squared minus 2m plus 1 equal to 0. Now use the back substitutions. Y double prime m squared, y prime m, and 1 is that. Okay, so y double prime minus 2y prime plus y equal to 0. That's our solution. So that's option A. Y double prime minus 2y prime plus y. Okay, now let's just figure out what could be the solutions, general solutions of options B, C and D. I'll show you one of them. You can try the test. Let's consider C. So it's y double prime minus 2y prime minus y equal to 0. Okay, y double prime minus 2y prime minus y equal to 0. Let's convert it to an auxiliary equation. M squared minus 2m minus 1 equal to 0. M is minus b, so plus 2 plus or minus root of b squared, so 4 minus 4ac upon 2a. So m is equal to 2 plus or minus, now how much is this? 8 root 8 by 2. So it is 1 plus or minus root 2. I hope I'm right. Yes, root 8 is 2 root 2. 2 will get cancelled. Now these are real and distinct. These are real and distinct. So that's c1 e to the power m1x plus c2 e to the power m2x. Okay, real and distinct roots. So general solution will be c1 e to the power 1 plus root 2 x plus c2 e to the power 1 minus root 2 x. Okay, now let's see if we have well, yeah, okay, let's consider D now. Let's consider option D. I think it has complex roots. Let's just figure out that. Okay, D, option D. Now, what is the auxiliary equation? M squared minus m minus 1 equal to 0. Okay, no, I don't think option D has it. Okay, which option did we consider now? Considered C, I guess. Okay, let's consider B. Sorry. Okay, let's consider B now. Okay, because it has a plus y. So y double prime minus y prime. Y double prime minus y prime. Okay. Plus y equal to 0. Plus y equal to 0. So that's B. Okay. So let me now make it plus. Okay. Now what are the roots? M is equal to minus b plus or minus root of b squared minus 4ac upon 12. Yeah. Okay. That's better. So m is now 1 plus or minus root 3I by 2. Okay, well, you might be aware of what the complex number is in the polar form, exponential form, but that doesn't matter now. This is now the third type, complex conjugates of each other. The real part goes with the exponent, so y is equal to e to the power x by 2 into c1 cos of root 3x by 2 plus c2 sine of root 3x by 2. That is how it works when we have a differential equation whose auxiliary equation has a complex conjugate roots. Okay. Well, I could go on. So let's just do one thing. Let's recall the differential equation of SHM. Okay, let's recall the differential equation of SHM. What is that? That is d2 y by dt squared plus omega squared y equal to 0. Right? So here the auxiliary equation will be m squared plus omega squared is equal to 0. So m is equal to plus or minus I omega, right? Because the real part is 0. So this basically tells us that y is equal to c1 cos omega t plus c2 sin omega t. Mind you, this is general solution. If you want a particular solution, then it will depend on the initial velocity and the initial position. Okay, that is how you determine the values of c1 and c2 as arbitrary constants. That was from physics. So that completes solutions to IISER Aptitude Test 2022 mathematics section, and the paper is available on the website. In my opinion, the previous one that I've uploaded, 2022 mathematics, has a better quality of questions, I would say, in terms of the difficulty level than the current paper which is available on their website. So I'll recommend you to watch both of my videos. Both of them will be extremely helpful to you. Last but not the least, we have launched free IISER mock tests for the upcoming exam. It includes 5 mock tests, and also it includes entirely solved previous year's question papers right from the year 2017 when this test was first conducted. The tests are free, the registrations are free, you don't need to pay anything, and the user interface is almost similar with the availability of the calculator as the actual exam. Many students have been benefited from this, so I would also like you to take the benefit and succeed in your dream of getting into an IISER. Thank you for watching and all the best for your upcoming exams. Thank you.